So Lonnie, this is my cover, so everyone can see. Okay, so my first page is solids. This is the picture. So basically, Bill threw a snowball at a flamethrower and it turned into gas. So there was enough heat that was gained in order to turn a solid to a gas. Basically, the second one he threw, it wasn't far enough or like close enough, so it only melted. So a solid could turn into a gas or a liquid. Alright, that's my second page. I'm sorry. So basically, Jill, Bill's friend, was cold, so she went inside to take a shower. She went inside and her popsicle melted. So basically, she was in the snow and eating a popsicle, so she got cold, but I guess like it still melted anyways because there was enough heat. So yeah, a liquid can turn, or a solid could turn to a liquid. And then Jill tried to check her face in the mirror, but the water evaporated from the heat, so she took a hot shower and it fogged up the mirror basically. So this shows that like a liquid could turn into a gas and the differences in how the molecules move. And for plasmas, after Jill was done, she turned on her fluorescent lamp to get dressed. And basically plasmas are when like it's not a solid, liquid, or gas, but when electrons can be moved.
Alright, so mine's next is my cover. For my budget, I only did samples of solid. So here's an ice, a rock, a plastic, a penny, and an apple. In here, the ice went to liquid. My solids went to liquids. The ice went, the ice melted, the plastic is melted, the penny is melted, and the rock is lava, and the apple went to an apple juice. Here are some examples of a gas, which is evaporation. Once the sun, I guess, connects or goes in water, it evaporates. Also, when you're in the sun, you sweat. That's another example. And plasma, here are my examples. And that is mine.
Alright, my name is Anthony, and here's my cover. Here, just for everyone to look. And starting with solids, basically a solid just takes a shape and keeps it. For example, from the game of chess, the king piece, it has to be kept safe from enemy pieces. Not very creative though. Liquids, it takes the shape of its container. Get a closer look. And for a knight piece, it must move in the shape of an L on a chessboard. For a gas, it has no particular shape because it is always in the air. It would tend to collide, and its atoms would tend to collide with each other in order to change the directions. And the queen piece can move in basically any direction on a chessboard. So basically, tell me if I'm wrong or not, but it's basically a free-for-all fight club.
And my other one is gas.
Okay, and a plasma is basically when it has equal positive ions and negative electrons. And in chess, there are always two opposing sides with a color for them to wear.
Alright.
Alright, you guys know me. But here's my portion of it.
What's your name?
My name's Robert Boone Jr. And here's my states of matter. But what's the matter with the states? Am I right? Alright. So solids usually is all by itself and its particles do not move. And it's placed and it never changes. As you can see, through these molecules, they're stuck together. And if you were to place it in some other object, it wouldn't change.
So you just create those.
Okay, so liquids would flow and cross particles at their own speed. In any direction, it will retain its form, and its form would change based on any type of solid it forms, whether it's on a flat surface or if it were in a cup, it would shape exactly like a cup. Gases are usually the most excited state, because all of its molecules are sporadically going around like if it were Six Flags. People are excited, but in this case, particles are the ones that are excited. Plasma is similar to gas, but adding some light, and its atoms are broken up into just protons and electrons, conducting electricity.
Will a fourth grader understand that?
No matter what form of change, they each have their own unique abilities.
Right here, Miss Morgado, Rodriguez, Rosales.
Alright, so I wanted a bar, not just any bar, a chocolate bar. But then I changed it up and hot chocolate came in mind, so I put it in the stove and it smelled mighty fine. Then I saw flames and my mom was to blame, so I couldn't drink it anymore because it wasn't gas. So who was to say gas was the last phase? Here came plasma and faded everything away.
That right?
Stefan?
The new member of the chemistry.
Alright. What's up, guys? My name is Stefan. This is my states of matter. You could have went, bro. Alright, so right here, fuck that. Solids have a set shape that is easy to change, and this is what I drew right here. Well, you have to show this, right?
Yeah. That's right.
For liquids, I put liquids have a definite size but not a definite shape, and then that's what I drew. And then for gas, I put gas has molecules that are in constant random motion. These are my drawings. And after that, for plasma, I put plasma is made up of free electrons and positive ions.
Byron?
This is my states of matter book. And
I don't think she can hear you. You should go closer.
Alright. Let me go closer.
Here, I'll record him.
Oh, thanks.
my states of matter book and too close. Solids.
Can you show us your book?
Solids are one of the three states of matter. Solids have a definite shape that is not easy to change. This is a pencil, little kids. This is a brick, a basketball, piece of wood, and a plate that you eat your food on. Liquids are the second states of matter. Liquids are found between solids and gas states. This is green juice. Apple.
That is
green apple juice. And that's a whole bunch of juice. The colors.
I've never seen a green apple juice.
It's just adding color.
That's a bendy straw. And gases. Gases is an air-like fluid substance which freely to fill any space available. And this is we put gas in the car. It's gas, little kids. That's a, you don't touch this, it's fire. It's a thing. And this is gas in a helium balloon. Plasma, get that, is an ionized gas consisting of positive ions and free electrons. There you go, kids.
Right. So, my story is about an ice cube. You know, once upon a time there was a little ice cube that was left behind. He was trying to find his way back home. And so, in the morning, it melted, so it became a liquid. Oh. And then, now, after it was a liquid, vaporization happened, so then the poor liquid became a gas. And then after it was a gas, it kind of got like electrocuted, so it had so much energy it became a plasma. And then he decided to just stay a plasma, but eventually he found his way back home.
As a plasma. Yay. Next.
Oh, Brianna. Alright, so my story is about a little girl. She was eating an ice cream cone, and then it started to melt because it was really hot outside. And then she went inside to try to save it, but it still melted. It melted into a bucket. So she went outside and tried to get rid of it, and then it evaporated. And then, as it was evaporating, lightning came and it struck it and turned into a plasma. And then, since it was a plasma, the girl went inside to get another ice cream.
Yeah, man?
We're done. We're stopped.
Wait, we still have Zachary.
She's gonna.
You don't have one.
He doesn't have one either? All right. All right, that's all we have for today. We'll see you next week.